So B3 lipids. So this is the other long one, and then after this it goes a lot quicker. So if we can get through as much of this as possible, the last few sections we can do lickety split. Okay? So lipids are. Have you learned about lipids in bio?
Yes.
Yeah.
Well, that's your fault.
It's not my fault. It's just my fault. No. Well.
See, I should have brought my dad stuff.
See, if they just brought some like 20th century history, I could maybe. Does he think he ever wants to?
What do you expect?
That's something like I look at.
Doesn't look right. It's for your two bitches.
Who's in bed?
He won't want to do that either. Is there a way to put your videos of this in like a Google folder? So no one's gonna eat it because
Why would they eat it? If they don't eat it, bring it to me after.
Oh, you mean
Wait, yeah, dude.
I do, but I can't give it away because it was for my tennis team.
Look at all this.
Hey, do you have food?
I have some leftover birthday brownies.
Really?
There's 4.
It's okay.
It's okay, I can't have one. It's okay,
I
I
can't
can't.
have one.
Perfect.
Okay, you can have one.
Yeah. And a chocolate muffin.
Yes. Thank you. Do you have any?
Where did you end up going?
So we went to Longwood, and we ate at a nice restaurant at Longwood, and then stayed for the fountain show, and it was really magical.
That's so cute.
That's such a cute birthday.
Thanks. And I got to walk wherever I wanted, and there were no children yelling at me about what they wanted to do, or that they were wet, or that they had to go to the bathroom, or anything. Okay. Also, do you know what this lipid is? A
Glyceride.
It is a triglyceride. So a triglyceride is a type of lipid.
What is she like try?
Yeah, I wouldn't have known that if you didn't say try.
Okay. Triglycerides are fats and oils.
I tried to do that.
I really hope that's something.
They're also phospholipids.
Oh,
Have you heard of those?
yes.
Okay.
Hate them.
Oh, sorry, hold on. Triglycerides are fats and oils, and they are used for energy storage, or thermal insulation.
So like blubber.
Yes!
So well.
What a great example.
Well, I just always think of that because does anybody remember when we had to like write about a Native American tribe in 3rd grade? We had to like be the person from it. I picked some weird tribe in Alaska, and they like had a lot of wailing or like blubber, and I just
Okay.
remembered it.
Phospholipids are in cell membranes, right? I hope.
The bilayer. No, you're right.
Okay. And used as electrical insulation in nerves? Does that sound right?
I'm not sure. You can go
Okay.
with that though. I'll record that.
He's still contemplating. Well, aren't they going to
No,
other
it's
Boston?
definitely too late.
Yeah, it's way too late. But we definitely should.
And also a third type of lipid, steroids.
Yeah, we learned about that.
It's like maybe 7:30 at night.
Which are hormones.
Why would it be 7:30? I don't think our game is 2.
When your game goes
I don't
short,
know.
It's gonna go to like 7.
Yeah.
and we're gonna learn about each kind in more detail.
Do you supposed to do your bio one?
I do.
I have to do the entire thing.
Yeah, same.
Well, I'm just not gonna turn it in before 8.
Don't have to turn it in.
And I was like, what?
Why did you turn it in?
Okay, ready?
Yeah.
Because it wasn't done.
Oh, no. Right.
I can't with your class.
So for fatty acids, we have saturated, all single bonds, unsaturated, where you have one or more double bonds.
I just don't have time. I have an AP test tomorrow and I'm not gonna get a 5
Yeah.
on.
It's taking up places from hydrogens.
Taking anything anymore.
Wait, first
I mean-
thing, why do you get 5? It's like, why do you get 8 if you're gonna
I feel honestly, the AP test though, like,
be doing so well.
No, I'm just not gonna get into college anymore.
No more negative talk out of you. You gotta tell that peak to shut up.
wait, that's what it, saturated is the carboxyl? No, that's just
Saturated is all single bonds.
Okay.
Fatty acids are carboxylic acids with long carbon chains.
Okay.
Saturated fatty acids have all single bonds. Unsaturated fatty acids have one or more multiple bond. And look at what that multiple bond does to the carbon chain.
It bends.
Yes.
This is kind of what I talked about in the bonus question, but
So with the unsaturated acid, we have a kink in the chain.
Do we have to know,
I'm gonna be your
isn't there like a word for if the carbons that are, I mean if the hydrogens that aren't there are on the
you're
same
taking
side?
the same year.
Yes.
So why not?
And no.
I didn't have to. But I still don't cut it, so.
So let's look at what this might do to some melting points, okay? We have 3 fatty acids here. We have stearic acid, saturated, nice straight chain. And stearic acid has a melting point of 70 degrees C.
It's something we should, know.
You don't have to memorize it, but you're going to have to apply it, and we're going to apply it now. We have oleic acid. If I can spell it right. Oleic acid, which is a monounsaturated fat. And that just means one multiple bond, right? And that has a melting point of 16 degrees C. Oh, look at what that double bond did to the melting point. My goodness. It went way down. Below room temperature, in fact. And then linoleic acid. Which is polyunsaturated, so it has a bunch of double bonds. And what do you think is going to happen to that melting point? Even lower. That's negative 5 degrees C. So saturated fats have high melting points. And unsaturated fats, specifically polyunsaturated fats, have low melting points.
It's just that it's kind of I watch just to understand it.
And let's talk about why that might be. If you have straight chains, they can stack on top of one another, get nice and tight, close packing, and so all along the chains you can have London forces. I wonder I'm in camera doing this. All along the chain, you can have London forces. So lots and lots of London forces are going to keep those molecules together and make the melting point really, really high because of all that attraction. So let's write that down. High melting point, close packing, increases the van der Waals forces.
Loose packing. No, close.
And I say it's the London forces that are increasing. But I encourage you to say van der Waals if it's a London force, because if you're wrong and it's not an induced dipole, it's a permanent dipole, saying van der Waals will get you full marks. So whether it's permanent dipole or London, van der Waals covers all of that. But if you say London and it was a permanent dipole, then you don't get the points.
Permanent.
Don't worry about it. Just say van der Waals if you're not sure. Either say van der Waals or say hydrogen bonding.
To figure out dipoles, we just use the electronegative number.
And the shape.
And the shape.
And so, because of this close packing and high van der Waals forces, you're going to have solids at room temperatures. Such as butter.
So that would be your fat.
Yes, exactly.
Okay.
With polyunsaturated, because of these kinks in the chain, now they can't stack on top of one another as closely. So the structure prevents close packing. And so you have weak van der Waals force, and you end up having a liquid at room temperature.
Do you think we should do fixed Like cold play?
It's the really sad song.
Such as
So good.
oils.
Not by us.
Yes.
So butter, saturated fat, solid room temp because of the close packing. Oils, liquid at room temperature, unsaturated fat because of the multiple bonds prevents them from getting tight.
Last year they
And I have a picture to show you.
Is it gross?
Yeah.
No, it's a molecule picture.
No way.
She had stuff through this year.
Yeah, she does.
That's insane.
I think the senior's gonna be okay though. I think we're gonna be okay.
What are we talking about?
Chambers. So normally people don't get cut. She got 40 kids this year.
Could you imagine being cut from
I just
chambers?
sophomore.
That would be so sad getting cut.
Sorry.
Sorry.
I know. Like they're coming under the radar.
Is it just one
They
class?
might be cut.
Yeah.
They gotta sum it up.
Yeah.
I'm worried I'm
What do
gonna
you
get cut
call-
because of my sixth major.
You're not gonna get cut.
No. I'm saying that
Oh,
because
yeah,
my
yeah.
sixth
Oh,
major,
it's not gonna
I
fit your
might not
schedule.
fit in my schedule.
You're still doing that?
Yeah.
Yeah. Why?
Can you be in
Because I
performances
wanna-
even if you aren't in the class?
No, probably not.
No, because
No,
you work
it
better
wasn't
than
what?
yesterday.
Like
Now it better feel.
the only reason I'm doing it is I want to be a bio major.
Oh yeah, she.
Okay, so
20th SL.
on the left we have saturated fatty acids, and see how they can stack right next to one another because it's nice straight carbon chains. But as soon as you put multiple bond in there, it kinks the chain, and so that now they can't stack on top of one another. So whereas you could have had London forces all along here, London, you can't have that over here. So you can have the interaction here, but then it stops. Or here, but then it stops. So the forces aren't holding them together, and so the melting point goes down. All right. Triglycerides.
Oh, I remember this. The glycerol has it all. If we learned this at the same time we're learning in bio, but I think this would click more and stay.
Mm-hmm.
Honestly, I don't remember anything for bio, so.
Maybe I can
really
start
fun.
scheduling my after-school sessions when she's teaching it. Or maybe like shortly after the test you take on it or something.
Yeah.
Well, the tests are broken up into
She called requests.
yeah, the quests, but they're broken up into like carbohydrates, and then you have one on lipids, and then one on enzymes.
Really?
Yeah.
I thought it was all like.
No, I mean a few of them were grouped together, but most of them were by themselves. Because then we had the whole thing about the.
If someone wants this brownie,
It's yours.
I don't care if someone wants it. Just be honest.
She wants it.
You can have the brownie. I've had plenty of
You
brownies.
want the brownie?
No, no.
Are you sure?
Yes. I brought them to school because we had so many left, and I knew they weren't going to get you.
Thank you.
You're welcome.
Do you want me to throw this out?
Yes. All right, so we know about condensation reactions. So here's my carboxylic acid, here's my alcohol. This is gonna get together and form. Good.
Yeah, Eden. Thank you. Did you figure out the whole like SIM card thing?
Yes.
She had a problem with it like earlier.
I made Bella do it because she's on yearbook. And shook her. But that's gonna happen. All three spots. Right? So you have to have one glycerol, 3 fatty acids to make a triglyceride.
When you bake butter.
Oh, we have to draw this, I think, on our exam.
And this is another Visser esterification, right?
Oh.
See, we
Because it's the alcohol
Yes.
and the carboxylic acid coming together.
Literally, I swear if I had this work, I feel like I'd have it better.
Honestly though, I
Not
think
gonna lie.
Miss Johnson makes you guys know
Yeah,
a lot
but-
more specific stuff.
So would another product
And
be
they
water
should be
then?
prepared.
Yes, and how many waters?
Now she
3.
3.
Exactly. Like everyone that was in your is gonna have like a challenge.
But I literally cannot stand it.
Yeah, I know. She loves
Listen, listen.
No,
We're
like-
recording. Wait until we are finished.
Right?
And then this
What do the apostrophes mean?
apostrophes. Oh, so R group, R group, R group. This just means that there's a carbon chain here. And because this is R prime, R double prime, R prime and R double prime could be different carbon chains. If it was R prime and R prime, they would definitely be the same. But because they're saying, you know, R prime, R double prime, R triple prime, they might be different. They don't necessarily, you don't have to have the same 3 fatty acids bonding up on the glycerol backbone. You can get 3 different fatty acids bonding up on the glycerol backbone, or you could have the same 3. But it just means could be different. Okay? Glycerol backbone.
Okay, I think it's time I should get my cough checked out.
Did you not already?
No, my mom refuses to take me.
Don't go to Med Express.
She took me there once.
That place is.
That's the newer one?
On 2, too.
On like when you're going towards Pennsylvania, the left side of 202?
Yeah.
They've been okay to me.
Yeah.
One time I went in and the person who treated me was a former chemistry student.
Huh.
That made me feel really old.
Wait, what?
I had taught the person who was the PA, the physician's assistant who was my prescriber. She's like, Miss O'Brien? Hi. She hooked me up though.
I mean, in a way.
I got an inhaler, I got an antibiotic, I got all kinds of
Doesn't
stuff.
it make you feel like a good teacher? Like my kid
Did something good with their life?
I was shocked that I was old enough that it had happened already. I don't feel that old.
You don't look that old.
Do you have to graduate college to be a...
You have to graduate college, and she went to PA school. Like, she wasn't a doctor, but she had gone to PA school.
Oh my
Yeah,
God.
see?
Well, you could think of it this way. You started teaching early.
I did. And she was one of my first chemistry students, so like. Okay, so are we good with this slide?
See, you're lucky. You can still braid your hair.
So just like we had talked about with fatty acids, with triglycerides, if your 3 fatty acids are saturated, you're going to have a nice high melting point because of all the London interactions. If your triglyceride is composed of 3 unsaturated fatty acids, it's going to be a much lower melting point because of these kinks in the chain. Okay? So what you were saying, I mean, this is a cis because they're on the same side, cis, but you don't need to worry about that.
Oh, the like cis
Cis-trans.
trans.
Yeah.
That was.
Do it. See if anyone cares.
The iodine number.
I just don't
People
get
just don't
random days
care.
before they don't care. It really doesn't. Like, I just don't draw attention to.
I think next year I'm gonna like.
I'm doing AP exam.
Oh, you can.
Wait, is it calculus?
You
I
gotta
mean,
really-
honestly, if you're gonna have to take it in college anyway, just like, then you'll just.
Yeah, but
It doesn't matter if you don't
That's
get the
gonna
credit
help you,
because
though.
you're gonna have a way higher GPA than being stuck in a class where you're confused.
Yeah, you're gonna do
You're
fine.
just gonna have to like, you don't have to.
It's just annoying because like I know there's gonna be people in our class tomorrow that are gonna get 5s, and like Sarah's gonna be like, oh, like you guys like should have all gotten
Manny's been doing
5.
practice tests for like
And
this
then
past month,
And
like
then
2 months.
I just don't have time for practice tests. Like I'm trying to do them. I don't know how anyone else has time.
Manny's at like 5.
Why didn't you do IB?
Manny?
Yeah.
It's
Well,
because
he's doing like
he wants
science.
yeah
So-
it's,
Oh.
yeah he wanted to do more
So
science.
I think
so
he'll be
he was
fine.
like-
He's showing up for football, so I mean.
When-
We learned this reaction too.
like,
Right? The halogen adds on either side of the double bond.
Yeah.
See that? So if you have 1 mole of this and 1 mole of this, you're going to get 1 mole of this.
Yeah, I did too. No, she quit. It was the best decision, honestly.
Well, we
I'm
have
still doing
it like
sports.
test or quiz
I just
on
couldn't do
kinetics
both.
before.
I just sucked
I don't
because you know
think
you
so.
were good
I
at
got
it.
But honestly, this is the first year I've ever been able to teach it, so I can't really say for sure.
What is it like the movement of energy that it takes to do
And
stuff?
rate of reaction and stuff like that.
Okay.
Yeah.
So it's not super complicated?
Yeah, but we have to have.
All right, and if we take this and put in some I2, remember the double bond is going to react with that, and we're going to end up having iodine on either side, and this will be gone. I just wanted to make sure that we remembered that. That's all.
Okay.
But the problem you would get is calculate the iodine number of linoleic acid molar mass 281. Now the first thing is either they're going to give you the structure, or you're going to be able to look up the structure in the back of the data packet. So like they have, if you flip to the very back of the data packet, after all the organic stuff, there's the amino acids. Remember we were looking at those? And then there's some lipids, carbohydrates, and nucleotide components.
Yeah.
I never understood
And vitamins, pigments.
That's the one thing I did was like over the thing that I just kind of like. I didn't understand it.
Don't understand what?
Vitamins,
Oh, I
like
didn't
that
know.
entire. I was like,
Did we learn about that? Vitamins?
We will. That's another, after the long lipids one, we have just a couple of short things after that. But let's look at this. So, you have to start with 100 grams of linoleic acid.
What? You guys should purposefully do that as peaceful
no.
protest.
Need to
No.
purposefully do
Wait,
that.
I'm
That's
thinking
not-
about
that's
it.
not- It's making it even more miserable. It's like already raining.
convert to moles of linoleic acid. I keep spelling these things wrong.
Oh yeah.
You just use one all the time of your triglyceride.
And they gave you the molar mass, 281 grams. Linoleic acid.
Yeah, you don't go.
For every 1 mole of, can I just put linoleic acid like that?
Sure.
For every 1 mole of linoleic acid, how many moles of double bonds are there?
2.
2. If you have room to keep going, keep going. I'm going to continue down here.
I feel like we should have had a game.
So far we've converted to moles of double bonds in linoleic acid.
That's like papers.
Yeah, to put it a little. Okay, but that might be out.
Is it the last 2 days?
1 mole of double bonds
It's not like I was winning.
reacts with how many moles of iodine?
2. 4.
1 mole reacts with 1 mole. 1 double bond reacts with 1 I2, right? That's the ratio. So it's a 1-to-1 ratio, but I just want to put it up there so you see the conversion. So I went from grams of linoleic acid to moles of linoleic acid, to moles of double bonds, to moles of iodine. And 1 mole of I2, I'm going to go to the mass of iodine. So molar mass is 254 grams of iodine.
Oh my god. Am I ever gonna get this?
And that gives me my iodine number.
That's so extra.
So 181 grams of iodine.
I'm just getting it.
So the iodine number of linoleic acid is 181. Because 100 grams of linoleic acid will react with 181 grams of iodine.
You guys want crack sprouts like that?
I do.
We do one?
Alright, I have 2 more. So this one is another example of a problem you might get, and then there's another iodine,
They would gather up money.
number 1.
I take 5
Evan, don't you think Eden would be good at soccer?
Yeah, egg, please. Why?
I don't have time for that either.
Egg, BS. It's in the fall.
She said she didn't home. I don't have work to do. Like,
So do we play sport.
I'm not gonna manage boys soccer.
She hasn't done it like.
Why? You're scared.
I am not following what we're talking about.
They want
Eden.
Eden to manage boys soccer.
We're basically talking about anything except
Yes.
This is
Just make sure you copy down the problem, that's all.
Okay.
So the first thing we're going to do is convert iodine to moles and linoleic acid to moles. So 7.7 grams of I2 to moles of I2 and 2.8 grams of linoleic acid to moles of linoleic acid. This is 254 grams. This is 278 grams.
That's
So I have 0.030 moles I2 and 0.010 moles
Everyone is sick.
linoleic acid.
I've been sick for like 3 weeks now. I
Why
don't
are
know
you
why I
at
haven't
school?
gotten better.
Stop coming to school.
I'm like, it's not really out.
I don't think people. I think people mistake their sickness for just allergies. Honestly.
No, I don't have allergies. I'm actually just been sick for a while.
See, I just.
I can tell the difference when I'm sick. It's fine. It's fine.
So then you're going to divide I2 by your triglyceride. So you have 3 moles of I2, and that reacted with 1 mole of linoleic acid. So that comes out to 3. See that? So that means there's 3 carbon to carbon double bonds. And if you think about it, that makes sense, right? 1 mole of double bonds reacts with 1 mole of iodine. If you had 3 times as much iodine, there must have been 3 carbon to carbon double bonds. Yes?
Yes.
Okay.
What
I
test?
felt like maybe like 2 bottles.
Okay, that's
It just made me so proud.
There's too many concepts to
it's like one
I'll be so
note.
Once
My brain doesn't have like a
But listen, the biochem is on a completely different day, isn't it?
Yeah.
Yeah.
So you can create.
So you don't have to worry about this until the last day. So we're gonna learn all the material, and then you're gonna take a practice exam on it, and you're gonna put it away until you take paper 1 and paper 2, and then you're gonna pull it out the night before.
Okay.
Okay?
what?
Yeah, I was gonna do that anyway.
My students so far have done very well on the biochem portion.
Okay.
But it took us
So
last
on
time.
that portion.
No, that's not true.
Yeah.
Because there were people who hadn't taken bio every year, and no one failed.
Olivia, you're literally smarter
So
than me.
for
Like
that
that,
test, isn't
Again.
there like part of it that everybody does and then yours is
Your
subject?
parents usually
You can do whatever
Yes.
you want.
My kid can just have
Alright, so here's another iodine number problem.
I say we revolt and not go to school after morning exam.
Sounds like the beak. Shut up.
No,
I don't want to go to exam. Classes after a morning exam next week.
We're talking about
Yeah,
learning
that's not
after
cool.
the IB exams.
This one?
No. The whole fact that you
Like,
have to
aren't
go
you
back.
gonna
and
go
forth.
great?
You've been complaining about the game the entire time.
I'm not gonna lead on.
Okay, so the first thing you have to do is find mass of iodine reacted.
They don't play anyways.
You're not coming back.
So you have 38 mils of a 0.5 molar iodine solution. Can you find the moles and then the grams of that?
Sorry, what am I finding?
You have to find the mass of iodine reacted. So first find the moles from the molarity,
Okay.
and then convert that to grams.
What if they don't show up?
Yeah. They're showing up regardless.
I was saying that
Who said
3
that?
people that don't play are coincidentally not going to be there. So,
He just extra. Who doesn't play?
setting up your.
I say he wouldn't
doesn't
do
Exactly, that's what I'm saying. Doesn't matter if they're not there.
What's in Phelan?
It's just the
I
fact
wasn't
that,
talking about
it's just the fact that you guys have them as an option. You don't have to worry about them. If they don't play anyways.
Well, sometimes it's nice because like
Maybe
when
I
we're
will
losing
stop.
by that much, then we'll put them in.
Exactly. But now you can't. We're gonna lose what? Guess how much? What's
You know,
better?
earlier I said 8-0, but I'm thinking.
10-0.
I'm hoping
It's
we
gonna
get
be
double
between
digits.
8 and 10.
really sad.
Watch us win.
We have to play really defensive.
What, you're not going to score on this once? No. They've been scored on twice.
What?
And if you did,
Like I feel like maybe we'll play.
I feel like you
You
might
might
play
put me in the back.
Soccer just sounds
So,
Like
I'm
I
not
could see
gonna
playing
lie.
wildcards.
So then once you find the mass of iodine,
Mm-hmm.
Yeah, she plays
Oh, the mass.
like.
What is the molar mass of?
254.
I mean, like, that's its regular thing. Okay. 54. And then times.
I can do
Okay.
So I got 4.8 grams of iodine.
4.8.
okay? How?
Yeah, that's what I got.
Okay.
4.8.
4.8.
Yeah.
So it was 0.5 times 0.038 liters
Yeah.
divided by 254 grams for the molar mass. I got 4.8. So at this point, if 4.8 grams of iodine reacted with 5 grams oil, and the iodine number is the grams of iodine that react with 100 grams oil, can you find what the iodine number would be?
Times 20.
How would you solve that?
Times 20, right?
Times 20.
Could you?
Yeah, sure.
I literally just guessed that. I did not.
I know it.
Care about center back, please.
So
So 96.
96. So the way if it's not an easy one like this, if it's not an easy comparison between 5 and 100, my go-to math strategy for proportions,
Yeah.
take a picture of this acid deposition page before you go.
I have to go too.
Oh, I have no idea what that was.
Put it in a group chat.
Just memorize this.
I might go on this because,
Egg, you do not have quality.
Yes.
no, I literally have to
What?
Stop.
No. That's HO.
Last year, Emma drank
Ew, guys.
Wait, what happened? For 5 minutes? This was last year.
Ew.
Oh my god.
Wait, Emma did
I
this.
can still hear.
Dude, that
Why
was
did she
so
throw
gross.
up?
So, if it's not an easy relationship between 5 and 100, say like this was 2.4 or something weird like that, you can just set up a proportion and then solve for x.
I feel
Okay?
like.
Wait, Mr. Brian, what time are you going till for this?
Whenever everybody has to go.
Thank you. I might come back. Yeah, I'm gonna go get food.
You're welcome.
Alright, I have to go.
What about Devin still there?
So now we have phospholipids, hydrolysis of lipids,
Can I get this video for me tomorrow?
yes, rancidity of fats,
That one they go bad.
there's like this much more. We're halfway. Keep going?
Yeah.
Alright.
Thank you.
You're welcome. Phospholipids are derivatives of triglycerides.
Did you just say derivatives?
I did.
Oh my god. I'm done. I can't. I don't like that.
Wait, it just means they come from it.
Oh. Christmas giving up.
So with a triglyceride, we have the glyceride backbone and 3 fatty acids. With a phospholipid, we have 2 fatty acids, and one of those fatty acids is replaced by a phosphate group. So right here is the phosphate group. Here is the glycerol backbone. This side is polar. And then we have over here the 2 fatty acids. And this side is non-polar. We good? Okay. So what happens is the polar head with the glycerol backbone and the phosphate group
I know what that.
all line up together,
I hated this in it.
Yeah.
and then the non-polar tails all line up together
Face
to
off.
form. Yeah, so like polars on the outside, non-polar tails are on the inside. That makes up the cell membrane. Cell membrane, right?
Yeah.
And we call this the phospholipid bilayer. Is that right? Okay.
Is this like, so is biochem kind of just like the basics of the bio part? Because for the phospholipid bilayer, there's like inner membranes and stuff like that.
We don't have to do any of that.
Okay.
The chemistry part is like the polar and the non-polar, and that and the actual structure. So like the phosphate group, these fatty acid things. The zoomed out stuff is the bio stuff. Because you don't actually ever look at what this looks like, do you? Not really. Okay. That is about it for phospholipids, I think. Next is hydrolysis of lipids. So we did condensation or Fischer esterification to make the triglyceride. Now we have to be able to do the reverse. And we have two hydrolysis. We have two ways of doing it. And you have to be able to draw the products of both. So we'll do an overview of each one, and then we'll do a problem with each one. So one way of doing it is acid hydrolysis. So if you take a triglyceride, add some water, and you have to do it in an acidic environment, so that just means extra hydrogen is present. So you indicate an acidic environment by putting an H over the arrow. And you gotta heat it up. You will end up with the glycerol, and then 3 carboxylic acids. And the carboxylic acids will be whatever these 3 things were. So you're just breaking it up and putting the H2O back on.
Sorry guys.
So,
See you.
bye.
Bye. Good luck with your game.
Thank you. Hey, where should we go?
What time do we need to be ready to leave by 4:45?
So what program am I using to put all of these videos into one thing? iMovie?
Sure.
Like, cause you know how it splits up into 3 videos whenever it's a really long
Yeah.
thing? I need them to be one file, and then I can put it on YouTube so that you guys can just go and watch it. iMovie. Alright, so this is acid hydrolysis. You can also do alkaline hydrolysis, sometimes called saponification. So you need NaOH and water and heat.
What did you say?
What did I say?
Yeah.
You need NaOH and water and heat. So this is doing it in a basic environment. And you're going to end up with sodium stearate in this case. But really it's soap. This is how you make soap. Or the salt of the fatty acid.
Oh, I left it at your house.
Yeah.
Thank you. Oh god. Yeah. Yeah. Yeah, yeah.
Did you use this
We had soccer for a little, and then we switched to tennis.
Alright, so if you were asked to draw the products or this reaction, if it's acidic hydrolysis of a phospholipid, here's your strategy.
Glycerol and carboxylic acid.
Mm-hmm. But what they are depends on what these are. So you're going to add 3 waters with H plus and heat, or you can put a triangle. Draw your glycerol backbone. So C, C, C. And now it's OH, OH, OH. And then put hydrogens where they belong.
Kind of want to what if we had like a study?
And then all you do is take fatty acid 1, put an H there. So it would be OH, C, O, and then R1. This might not be R1. This might actually be a chain that you have to redraw. So all you're doing is matching whatever that is. And then this one.
God,
This one is R2. Or draw whatever the chain is. Oh, sorry. This is if you have a phospholipid. So, let me go back. Triglyceride if you had acid hydrolysis. You just get the 3 fatty acids, right? Triglycerides if you do with saponification. So all you do is take that, and it's COO, and then sodium on the other side, right? This is if you have a phospholipid, so it's the same thing, fatty acid, and now I have the phosphate group. So that just turns into this guy. I'm putting an H over there. So it just ends up being H3PO4 to make it easy. It's just phosphoric acid. But if you want to draw it, in each case, all you're doing is plopping the H back on. Boop, boop, boop.
Wait, so the phosphoric acid is one of the products?
Yes,
Okay.
because you're cutting it, right? You're putting the OH back on here on the glycerol. So the OH goes back on the glycerol, and then you get the carboxylic fatty acid. You're putting the H back on here, which turns it into H3PO4. And then with alkaline hydrolysis of a phospholipid, again, it's the same thing. You're making the glycerol backbone. So in this case, you need sodium hydroxide. You actually need 5 of them. And let me go back to this one. You would need 3 sodium hydroxides to do this. Because you need sodium, 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 hydrogen, hydrogen, hydrogen. Here you need 5 sodium hydroxides. And heat. So you'll get your glycerol backbone.
See if it's cold outside.
So this one, so this is an O, and you're plopping a sodium on the other side instead of a hydrogen this time. This one,
He's what?
He gets kicked out once a year.
is he gonna get kicked out today?
Oh, there's a possibility. Yeah, I could see him getting kicked out today.
Putting a sodium on the other side. And then for the phosphate, you make a phosphate salt. So this one is going to be Na3PO4. And you're going to have 2 waters. So that's why you need 5 of these. You need 5 sodiums total. 1, 2, 3, 4, 5. And we can stop there and just restart with rancidity of fats.
Okay. Rinse.
And then we'll finish that.
Thank you.
Thank you.
Thank you.
Camera is on. So, rancidity of fats.
Oh my god. I'm such a terrible person.
Oh boy.
I forgot to meet with Carter's mom. Will she
Nurse
ask-
Stephanie?
I have her. No, I had Miss Hendricks as my EE advisor, but I need to talk to Miss Gramia because what's she talking about?
I might interview the person who wrote my book.
What is a disagreeable smell?
Bad smell. Yeah, so like fish oils taste and smell.
What does that say?
Causes a disagreeable smell, texture, or appearance.
I don't like the texture.
You can expect that. Do we do stuff with like those big structures I saw on the first slide? Like, did I
Yes.
miss that part?
Yeah, so like we did, like making a triglyceride from glycerol on fatty acids. We,
I remember like 10. Actually, no, 20 minutes. I really don't like a practice.
we broke them apart so we did the reverse. right? And you can do with acid or a base or with phospholipids.
Okay, so that's something I can like catch up with.
You're putting it together, breaking it apart, and it's just the Fischer esterification reaction in forward or reverse. So you've done it 1,000 times.
It's just like organic, but
Yes,
a little more.
yes. But like the easy part of it, where you're just like, oh, you would just put that together and you just draw it. So one way that fats can go rancid is through hydrolytic rancidity, which is just a hydrolysis reaction. And this occurs more quickly in the presence of heat and moisture. And catalyzed by enzyme lipase. Is that how I say that?
Yeah. Hey, that's what I used, or not used, but like that's what my bio thingy that she made us do. It's like it's just an enzyme.
Cool.
See, why do you sometimes say CH2 and H2C? Like, why is it?
Does it matter?
Because the bond is between the carbons. So they put the hydrogen on the other side because that's bonded to the carbon. But like this bond is between these two. So this right here on the triglyceride, this guy, that's the site of reactivity.
Wow.
And I don't know if you remember, but what's this functional group? The O with the double bonded O next to it? Ester. And that's the ester, the site of reactivity is the ester linkage.
And now I kind of forgot that was like next week.
I feel like I have not been in chemistry.
Oh no, I'm not
It's kind of like the year is over. And
That's how I'm thinking about it. I'm just
I
like,
don't like
really
that. I really don't.
But I
like
have
that.
like all my major assignments left. So
I know, and they're all at the same time.
guys, but like we're almost done with junior.
So are we?
Isn't next year supposed to be worse?
Not
The
for me.
beginning, yes, it is.
Not for me.
Well, yeah, you'll be.
Yeah, because you're not gonna care.
She'll be in college at this point.
So it's just a hydrolysis reaction where you're breaking up the triglyceride into the glycerol and the 3 fatty acids. And the rancid smell is due to the release of the fatty acids.
What does R1 mean?
That's just the R group.
And they'll say like R1, R2, R3 because they could be the same chain, but they could be different. If they all say R1, they're definitely the same chain. If they're numbered different things, they could be different ones. Due to release of, fatty acids. And it can be reduced by refrigeration.
So is that why you store your fish in the?
And it doesn't sound bad.
In general, chemical reactions happen more slowly at a lower temperature.
Oh, that's why fish smell bad? Is that what you're talking about?
Yeah.
They're more pungent when you're.
They have a lot of fatty acids, and fatty acids don't smell good. Can be reduced. Can be, I'm trying to write reduced. Can be reduced by refrigeration.
I had a good time seeing you guys later.
And also because these movies are so huge, they're taking up a ton of room on my computer. So like doing anything with them is really hard. So I need to like make a video and delete all of them, and then make a
Yeah.
video and delete all of them.
Yeah, it takes like 10 minutes just to download.
Like I'm getting really backed up. And they don't need to be high quality, you just need to be able to see in general what I'm doing and hear me.
Here you go.
If not, like, just all across the ones from.
I'm almost done. I just need to pull last.
Are we good? Alright. Oxidative so another way it can go rancid is oxidative rancidity or auto-oxidation.
Where is everyone?
I guess it's the last soccer practice.
Yeah,
Oh, lucky.
because they did not do well.
So this is catalyzed by light or enzymes and metal ions.
What's an example of that?
I'll get back to you on
Is
that.
that important? Do we have to know that?
I don't think so.
Never mind. I meant to ask you, whether you ever looked up what, this is from,
Yeah.
or I don't know what student this was, but it was like paper chromatology.
Chromatography?
Yeah, and it was like, what is the normal structure of amino acids, like, called? Like,
Oh,
what's that
right.
in-
I do have to look that up. I have not.
Right.
Uh,
I wrote a note down.
This occurs in fats and oils with a high proportion of double bonds.
Why is my handwriting so long?
So what happens is that you're adding oxygen across the double bond. So we've seen halogens get added, but instead with oxidative rancidity, the oxygen gets added across double bonds. I'm gonna scroll up so I can write a little bit more. And it can be controlled with antioxidants.
So, like,
It'll prevent the oxygen from adding.
Wait, I think it was in my IA, can I talk about antioxidants and vitamin C and how that helps with like collagen or
Mhm.
something?
Yeah, it prevents the breakdown of the fats.
So it just makes your skin like, it prevents it from having like cellulite and all that stuff.
Maybe? And the sites of reactivity in this case are the carbon-carbon double bonds.
there's just so much we have to know for this exam that I do not.
I'm gonna send my list on Wednesday.
Well, remember, this is the last one. So we're gonna get all this information down, you're gonna take a paper 3, and then you're just gonna not worry about it until the night before.
Wait, this is paper.
No, we're about the entire exam.
No, paper 3 portion.
Oh,
Our time is the second day, and everything else on the first day.
Mhm.
So I'm going to say everything else is up.
Biochemistry.
day 3.
Until Wednesday.
Biochem is day 3. So, yeah, this is day 3 problem.
I mean, I'm talking about the other.
I know,
6.
one thing at a time. One thing at a time.
I started doing those.
Okay, energy.
I can't really, like,
Both carbohydrates and lipids are used for energy storage.
oh, I remember like one's like short term, one's long term.
Yes.
So that's lipids are long term. Carbs are short term.
you even thought about like doing some essay since your last meeting?
Nope.
That's why I was in the library checking out some books. Except for Miss Kenny used all of them for her class.
Oh.
So I couldn't get any of them until like now.
Oh.
Except
No
for
one
the
didn't think
library
about
hasn't
it.
put them all back.
Or doing
So now I can't access any of them.
Yeah.
I literally haven't even thought about it.
I'm actually pretty hyped. I know I'm probably gonna get stressed and cry, but like, I'm hyped.
Well, that might just come.
No, cause like,
This is me.
I can just predict when I'm about to cry. Like, it's gonna happen
Sometimes you just need to. I'm not gonna lie.
next week during the exam.
So carbohydrates have less energy. Lipids have more energy. Carbohydrates are polar, which means that they're soluble in water. Lipids are nonpolar, so insoluble in water. Insoluble
So
in
that
water.
Wait, so then why do people like, or like athletes before the day before they like have something?
I'm gonna tell you about it in a second. But I'm gonna scroll down so that we have plenty of space to write.
Oh god, it's got it. They're so cute. I feel like practice is gonna get canceled, I'm not gonna lie. I can sense the new students' books.
Okay. I'm gonna scroll down a little bit and then extend the page. So remember, carbohydrates, lipids, carbohydrates, lipids. So carbohydrates are more rapidly transported in the body.
I love how my mom is like, she's like talking about this calc exam like she has taken it before. She's like, no, calculus AB is calc 1 and 2. I'm like, I don't even know what it is. And my sister's like, it's hard. All I was just like,
So carbohydrates are more rapidly transported in the body because of the solubility. You are mostly water. This is soluble in water. It's going to be transported easily. And so it's used for short-term energy supply.
so that's like a healthier way of having energy for like performing.
Well, this is why like athletes carb up before they go run a race because it's easily accessible by the body and transported easily. So you're not using up energy trying to access the energy itself or the fuel.
It's efficient.
Yeah. Lipids are more slowly transported. Used as long-term energy storage. The ratio of hydrogen to oxygen is greater than over here. Which means that it's more reduced.
So how does lipid energy storage result like that whole dieting of ketosis?
Hold on. I can tell you what I think, but I don't know that I'm 100% right on that.
I'm gonna finish this slide and then leave. You know, I really don't want to get this.
Unoxidized, they release more energy than a carbohydrate. So I think that the whole keto diet thing is where you don't give your body any access to the carbs,
Right.
so that it must break down the lipids and fats and to use them for energy
But
instead.
I'm kind of
But how does that have anything to do with? Does that have anything to do with?
It makes
ketones?
ketones.
Oh, it makes them.
Yeah,
ketonic.
but that's where the ketosis is, because you're converting things to ketones.
Oh, wait,
Hello.
ketosis.
But yeah, but like athletes who do keto have to. I've read. There are some like athletes in my running group who do keto. So like before a run, they can't eat carbs for the short-term energy, and so they end up being really, really tired. And the way they get around that is that they fast before a race, so that their body is already started to use this, instead of waiting until halfway through the run for it to start doing that.
See, like,
Isn't that crazy?
It's just so you just have like kidney failure, so that's kind of not
I don't think it's for everyone, but honestly, I don't know enough about it to talk
There are like different
about it.
like medical reasons why you do it. I don't think it's supposed to be
Well, like my friend did it, and then I was like watching her, and I was like, "You're gonna pass out."
I just like food. Yeah.
It's a good like emergency point. My stuff in guidance. I'm afraid they're gonna lock it.
Okay, I'm at a dip. I don't want to, but apparently everyone left.
What?
I'm still trying.
I have to catch
Go
up
back?
for ransom because they
Oh,
don't
yeah,
want
we're
to
gonna
bring.
The video? Yeah.
I'm so sorry.
That's
Alright, I'm gonna get my bag because
Like, they just left without me.
it's
Thank you.
Do we have homework due tomorrow?
No, we're having an organic chemistry quiz, and we're starting
The other thing.
kinetics, and then you have a test on Thursday.
Okay.
Wait, so then does my class have an organic chemistry quiz?
No,
Friday.
yours is on Friday.
I'm not gonna do that.
We'll work it out. Okay, so you use a bomb calorimeter to calculate energy content. And we talked about this a little bit in class itself. But you do a little reaction inside here. The water absorbs the energy. You measure the change in temperature of the water, and you do some math and figure out how much energy the thing had. And we're gonna do a problem like that. And then steroids, and that's it.
Oh, we're done. Is that everything? That's everything?
No, so like let's start the problem.
Okay.
Okay, so.
So many people wrote so many fairy tales. I thought fairy tales was a small topic.
What are you talking
It's very big.
Is this for your EE? You're doing fairy tales?
Well,
Can you just focus on one author, like Hans Christian Andersen or something?
Well, see, that's where it gets difficult because I decided I was gonna compare three and then like look at how they evolve. But I have to be really careful with that because of like the way that the English requirements are set up. I have to use something that isn't translated. So like I had to narrow myself to like what time period, but like finding things that aren't
What's this one about energy?
translated is rough.
You use a bomb.
And then I also have to like watch the Princess Frog
You
movie,
just
but there's no
to calculate energy
screenplay
content.
for it.
You
that I
use a
can
bomb.
find.
Okay.
So I'm gonna have to sit there and watch it.
Okay. At least the music's good. Alright, so. So, a 2-gram sample of cheesecake, 6% of it is protein, 44% is carbohydrates, and then the rest is, well, not maybe, the rest is some other stuff, but we have unknown amounts of fats and water. you put this sample in the bomb calorimeter, burn it up, and the bomb calorimeter measures 37.4 kilojoules of heat to be released. So we're calculating how much fat and water was in the cheesecake, and we know these other things. So the first thing we're gonna do is find the actual grams from the percentages of protein and carbs. So the sample was 2.0 grams. 6.4% of it was protein, so that comes out to 0.128 grams protein. All I'm doing is multiplying by the percentage as a decimal, right? 2.0 grams of carbs comes out to 0.89 grams of carbs. Now I've forgotten what I did.
The other one.
The rest of it. Wait. Why did I multiply by 17 kilojoules per gram? Is that from the...
If you the IB exam, would you like do all right? Or are there just too many things that are just like
Mr. Brian.
I mean, like, obviously knows the material, but like memorizing all of it, you don't like.
I wouldn't do that great on the biochem because I'm not good at it. But the rest I think would be fine.
Doesn't my IB like this obscure stuff that like
They do weird stuff. Well, like I take it, I usually try to take it the same day that you take it so that you can come and compare what you did with me. Okay, so
I hate that we can't ask questions.
I know.
Can you ask questions?
let's knock this out and then we'll chat. Carbohydrates and proteins release 17 kilojoules of energy per gram. Okay? So we're going to figure out how much energy was released if we had 0.128 grams and 0.89 grams of each thing. Now this is easy because all I have to do is multiply each thing by 17. It's not two different things. So like I'm just going to cut down on the amount of... So 0.128 plus 0.89 times 17 kilojoules per gram. I was able to add them together because they both release 17 kilojoules per gram. Okay. Do you see what I'm doing there?
what if they didn't do it?
Then we would multiply them each separately. Like, if it were fats, like say this one was fat, I would do this times that,
I hear you
and then this times
Yeah.
that,
And then add them.
and then add them. So 17.3 kilojoules of heat were released by just the protein and the carbs. So how much heat was released by not proteins or carbs? How would I find that?
Should we set 7.4 minus?
Exactly. So 37.4 kilojoules minus 17.3 kilojoules equals 20.1 kilojoules from fats.
And water,
Well, why? Water. Why did I do this? Oh, I understand. Water doesn't store any energy. It's just water, right? You get nothing from water other than hydrating your body. You don't get any energy from water, right? So all the other energy is coming from the fats.
What is energy?
Isn't the
I don't think I want to know.
There's potential and kinetic. It depends.
I'd rather just.
But like,
say-
you don't,
Thing or
it
it's
needs
just
to
a
know.
term technically?
Is it a thing? It doesn't have mass, if that's what you mean,
Yeah.
but it can be converted into mass.
Like ATP is energy and that's a thing.
No, I get that, but like,
But like you can't hold it.
yeah, that's what I'm like.
So
And like atoms are, I mean, like.
if 20 kilojoules are coming from fats, we're gonna convert that to grams. So 20.1 kilojoules from fats. According to our table up top, 1 gram of fat will release 38 kilojoules of energy.
We will get a table, right?
Yeah, they would give that to you. So that comes out to 0.529 grams fats.
Actually, take out my quadratic formula. On my calculator.
You can get Ms. Miller to put it back in.
Should we clear everything?
They clear what?
I don't know if they're going to or not.
I cleared calculators apparently. In the bio fix there.
Who does?
I give you
So,
IB people
the
there.
monsters.
I had
I don't know, I heard they can't clear calculator. I use that calculator.
I had 0.128 grams. I had 0.890 grams. And then from the fats, I had 0.529 grams. That equals 1.55 grams of fats, carbohydrates, and protein. How big was the sample?
2 grams.
It was a 2 gram sample. So this is all the other things. So how much water do I have? If the sample was 2 grams,
Wait, I'm sorry.
0.45
Can you ask
There
the
we go.
question you said?
I had a 2 gram sample.
Okay.
This was protein maybe? This was carbs, I think.
Yeah, you're right.
This was fats. So that's all of the things together. The only other thing in it was water. If it was a 2 gram sample and 1.55 was these other things, then the water must have been 4.45 grams.
Yeah.
Right? Okay.
That's the answer to the question.
So then the last question was calculate the percentage of fats and water in the cheesecake. So
Isn't that
fats was 1.55 over 2 times 100.
I thought that was 1.5 is all.
Nope,
of
just
them.
kidding. 0.529. No. The notes I scanned in are wrong. Sorry, friend. 29 over 2. And water would be 0.45 over 2 times 100. Let me fix that. So at least it's fixed for next year.
How long is this next section?
So steroids are 1, 2, 3, 4, and then that's it.
What button is?
Okay,
Or the answer.
this is pretty quick. Steroids are lipids with a structure consisting of 4 fused hydrocarbon rings, like this. This is cholesterol. It's a steroid, but it has this ring thing we're talking about.
Cholesterol's a steroid?
Apparently. And these 4 fused hydrocarbon rings are called the steroidal backbone, or steroid skeleton. Steroidal backbone. And they have, in the back of the data booklet, it's vitamins and pigments. I thought they had steroids back here. Maybe I'm wrong. Vitamins. Maybe not. Maybe not. I have written down here cholesterol transported around the body by lipoproteins. You heard of that before?
Yeah.
Should I write that down?
Yes, please. Why not? Yeah. Alright. So we have HDL and LDL. We have high density lipoprotein and low density lipoprotein. Have we heard of those before? So they're the good cholesterol and the bad cholesterol? Okay. So high density lipoprotein removes cholesterol from artery walls. Low density lipoprotein transports cholesterol to arteries. That says transports cholesterol. To arteries where it leads to thickening of the arteries. And the cholesterol, it's coming from, it says the source, saturated fats. So the little picture is the LDL guy dropping it off in the arteries and the HDL guy doing his best to remove it. So you want that when you go to the doctor, you want your HDL number to be high as possible and your LDL number to be as low as possible.
Wow, I just realized what HDL and LDL is.
And you can see the difference between the densities, right? Hormones are chemical messengers.
Remember that?
What's it called?
You might be asked for some uses.
Yeah, almost paid for it.
Oral contraceptives.
That's a name for bio, do you ask me
HRT, hormone replacement therapy, for like women in menopause or something like that.
What do you need to do for menopause?
So when you're in menopause, your body stops producing the hormones that you would need to reproduce, right?
Yeah.
Your baby making days are over. But the loss of some of those hormones can cause other problems, like if you hot flashes and other uncomfortable things that women in menopause really do not enjoy. So hormone replacement therapy is you take synthetic hormones to replace the ones that your body isn't making anymore to solve some of those problems. Like some serious problems like osteoporosis and stuff like that. You know? You can also use them to build up muscle. After an illness or an activity. Which brings us to the last slide. The use of anabolic steroids. Which are synthetic drugs. That mimic the effects of testosterone. And other hormones. Testosterone. That accelerate protein synthesis and cellular growth. Synthesis and cellular growth. Especially in muscle and bone tissues. So let me just move this picture down a little bit so you can see it better. The only difference between testosterone and this guy is this one single substituent right here. See that? And that can be easily added or removed to create that drug. Health risks. Did you guys learn about these in health class?
We didn't really do much.
I
didn't
learned
get
about milk in
Milk?
soy
The only thing
cream
that we
and
were told is we were never allowed to drink. Wait, was it that we were never allowed to, or we had to drink raw milk?
Yeah, we had to drink raw
Is it
milk.
raw milk or no milk?
We didn't.
Like not pasteurized?
Yes.
Yeah, we didn't even learn CPR.
Like she made that a huge deal. That was a good 2 or 3 class unit.
On milk.
And we also learned about like the effects of medical marijuana.
Oh yeah.
Yeah, because they were like going between health teachers at that time, and it was just.
Okay. So health risks, which is, you know, you could also maybe find on an after school special. Acne. High blood pressure. Liver damage. It can suppress the production of natural sex hormones. So if you're giving your body fake testosterone, it's not going to keep producing its own testosterone. So, suppress production of natural sex hormones. And it can increase your LDL cholesterol level, which we also just found out is bad. And that's it
For today or just?
for B3. And that was the last long one. So after this, we have, let me just make sure, I think we have 3 more short things. Carbohydrates, vitamins, and biochem in the environment. Yes. So we have 3 more after this, but they are much thinner. Like vitamins is this. Carbohydrates is this. And chemistry in the environment is another little one. So we could knock that out feasibly, I think, in 1 longer afternoon or 2 short afternoons. And be done. I'm going to turn this off.